Now that we're getting into some standard kind of AI and machine learning models, I want to just go over the standard or kind of a common machine learning pipeline that we'll see in this unit and in future units. If you've had some other data analysis classes, you may have seen something similar. So the idea is this, what is our standard process for creating a machine learning model. So we usually start with some data that we have to import. So we have some file, which is our original data set that we bring in. And then we usually clean, scale, normalize, things like that to it. So we do some cleanup for it. And then so we have a cleaned data set. So once we have that, that's what we'll be using for that. And again, we've kind of looked at some of the basics of this, but there's more that you can be doing for that. But so once we have our clean normalized data set, we generally divide it into, if we're doing supervised learning, two things, an input and an output. So we say, what are the features that we're going to use for the inputs, and what is the feature we're going to use to predict the output? Now, if this is a number we're predicting, it would be a regression model. If it's a category we're going to be predicting, this would be a classification model. And so again, usually the Y output is just a single value or a single thing we're going to predict, and then the other select features are the inputs. And we usually use these terms X and Y as the input and the output. So once we have those, we're going to divide them up into some training data and some testing data. So generally, commonly we might put like 80% of the data over in training and 20% over in testing, or 90% over in training and 10% over in testing here. So then we have this training data, maybe 80% of our data. And again, we have the X, we have 80% of the X and 80% of the Y, of the inputs and outputs. And then we train our model there. So again, this is supervised learning. We're giving it an input and the output that should match, and fitting the model to that, or learning or training the model. So again, we repeatedly show it the input and the corresponding output and fit the model. So again, we do some training. And again, this can take a long time. Right now with our simple model, this doesn't take long, but eventually this might take a while to do because we have a larger data set and larger models. So from this training, we end up with our model. And then we want to evaluate our model. So now we take our testing data here and we feed that into our model, and we give it a test input, and it should predict a result, and we compare that to the actual result it should be getting, and then we can score the model on how accurate it is. So notice when we're training the model, it never sees the test in the testing input and outputs. So we train the model on just the training data. Once we have the model, then we use the testing data to test out the model and generate some score or some accuracy of our model for this. So this is a standard train test kind of approach to our model. Now, once we get a model, we know the score here. We can then use that model to make future predictions and put it into production. So this is our final model we have. Now there are other ways of doing this. Sometimes we'll take our data and to break it up in like 5 parts, what we call folds, and then train it on 4 of the folds and keep out, and then have a way of training in all the data, but do some separation there. There are other ways of doing this, but this is by far the most traditional one, where we have this train test split for our model. So I just want to kind of go over that and explain that, and we'll see this on almost all of our models going forward here.